Section 5.5 continued. On the previous videos, we learned how to solve quadratics by factoring and by using square roots. In this video, we want to learn how to solve quadratics by graphing. And to do that, we need to find an x-intercepts. That allows us to use the zero of a function. Any value of the variable for which the function is zero will give us a solution. On a graph of a function, each x-intercept represents a zero. This is the procedure to solve using tables and graphing. 1, we still have to get the equation to 0 and to order the terms. 2, use the y-editor or y equals button on the calculator and enter the function from step 1 and then press graph. Then we can see what the graph looks like. If we need to, we can set the window to get it to fit the graph that we need. Number 3, then press second graph on the calculator. That will give us the table of the graph represented in number 2. Use the table to determine where the sign changes occur. In other words, where the y values go from negative to positive or positive to negative. And in between those values will be a 0. Number 4, then press second trace and select 0. That will help us calculate our 0 of a function. Number 5, use the left and right arrows to toggle left and right to enter the boundaries. In our first example for solving quadratics by graphing, I'm going to use one that I solved in our previous section. In the previous section, I had to use some of the same methods in this section to solve a quadratic. For example, I had to get all my terms on one side and then order those terms. In the previous section, I solved this by factoring. But what I did was, if I have a general form of a quadratic function, it's going to be x squared minus 4x minus 12 equals y. In this situation, my y became 0 when I subtracted 4 on both sides. If you recall, when we graphed functions, if I set my y value to 0, that actually found my x-intercepts of the function. And here, when I factored, I determined my x-intercepts. They are 6, 0, and negative 2, 0. That's where they intersect the x-axis at. The function will intersect at those x-intercepts. And that's what I'm trying to find by solving this by graphing the 0 of the function. To do that, I'm going to use the procedure on the previous slide. Again, I'm going to set my terms to one side of the equation and order them. Then I'm going to enter my y value into the calculator, which is x squared minus 4x minus 12. So let's bring up our calculator. I'm going to go to y equals, and I'm going to enter x squared minus 4x minus 12. Now, I'll graph that function. And I can see that my vertex is below my visible site here on my screen. So I'm going to go to my window, and I'm going to reduce my y min to a point where I can see it. So I'm going to select, and I'm just guessing, a negative 20. And then go to graph. And you can see that I do have my vertex, and I can see a better part of my quadratic. Here are my intersection points of my x-axis. Those are my x-intercepts, or the 0 of the function. They had better be a negative 2, 0, and 6, 0. Let's verify that that is the correct solution by factoring and also by graphing. They better match up. So what I want to do is go to second graph. That will give me a table. That will give me my x values, and that will give me my y values. And I want to see where my zeros are. And notice in this instance, since they are whole numbers, what I want to see is where they're located at. And notice my first x-intercept is 6, 0, and I can go back up and find my next intercept at negative 2, 0. So you can see that that actually does work. But what if they aren't whole numbers? What if they're not integers? Well, then I'm going to have a more difficult time. What I need to find is where my y values are changing from positive to negative or negative to positive. So you can see here's my 9, and here's a negative 7. So I know there's a 0 in between. In this case, it's a whole number. But how would I do that in a different circumstance? What I would do is press second, trace, and now you can see they want me to calculate a 0. So I go to 2, and now it's asking me for a left boundary. And what I do is I hit the left arrow on my calculator, and I want the left boundary. That is the closest x value I can get to the 0. So here I'm at a -2, and I have a y value that is positive. I'm above my x-axis. I press enter. Now I'm going to scroll down until I get a negative y value. It's actually the next tap on my arrow. And so now I'm above the y-axis, and my next one's below the y-axis. I hit enter, and it should give me a guess of what it is. So I hit enter again, and notice it gives me a -2, 0. So I am correct. Now all I would do is press second trace again and calculate the 0, and then I would scroll over to my other 0, or where my axis is going from negative to positive or positive to negative. That's my y values. The left boundary, of course, is to the left of my possible intersection point. So here I have a negative y. I press enter, scroll. I still have a negative y. Now I have a positive y. Press enter. It will ask you if you want it to guess. Press enter again, and it will give me 6, 0. So you can see by graphing and by factoring that I will get the same solution by using these methods. Our next example is x squared minus x equals 1. Let's get all our terms on the left side, which is x squared minus x, subtract 1 on both sides, and that equals 0. I also can write that as x squared minus x minus 1 equals y. The reason why I want to graph is because I cannot factor this, and I also don't have the correct terms to actually find the square root version to solve the quadratic. So I need to graph. So let's bring up our calculator. Y equals, I'm going to clear my first graph, and I'm going to enter my new one, which is x squared minus x minus 1. And before I graph this, I'm going to go back to my zoom, and I'm going to hit 6, which is my standard graphing form. And as you can see, my quadratic appears. I have 2 x-intercepts. I don't know where they're located at, but to help us out, I can go to my table. So I'm going to hit second, graph, and I want to find where my values go from negative to positive or positive to negative on my y values. So if I scroll down, I can already see one that I go from positive to negative, and that's going to occur between a -1 and 0. Notice I need to find out where my y value is 0. It goes from positive to negative between a -1 and 0. So I know my first one's between a -1 and 0. So my first x-intercept is between that location. My next one is located between 1 and -2. Why? Because I go from a y value of a -1 to 1. So my next one's between 1 and 2. So let's bring our calculator back up. I press second, trace, which will allow me to calculate. So I press 2 because I want a 0. And notice I'm going to scroll between a -1 and 0. So notice I'm at a -0.8, and I have a y value that's positive. That's good because now I need it to go negative. So I'm going to press enter, scroll to the right 1, 2, until I get a negative y value. I finally do. I press enter again. It asks me to calculate. I press enter, and my value is a x-intercept at a -0.618 or a negative 0.62, comma 0 is my first y-intercept. So my solution is a negative 0.62. But I know I have another one. So I have to go back to my calculator. I'm going to press second trace again, number 2, because I want to calculate. And now I'm going to trace over to the other intersection point. To the left of that point is below the x-intercept, so I want my y value to be negative. And I know it's got to be between 1 and 2 on my x value. So here I'm at 1.4. That's between 1 and 2. I have a negative y value. That's pretty close to my intersection point. I'll press enter. Now I'm going to keep scrolling till my y value turns positive. Now I got a y positive value. I'm going to press enter again. It asks me to guess. I want a left boundary, so that's going to be to the left of this intersection point. And I'm going to get 1.62 for my x-intercept. And notice, negative 0.62 is between negative 1 and 0. 1.62 is between 1 and 2. That's how we located those values on the table. And then to be more accurate, we calculated them on the calculator. So these are my solutions for this quadratic. Negative 0.62, 1.62, and those are also the x-intercepts. Let's graph one more quadratic. Let's bring all my terms to the left. That gives me x squared minus 2x minus 4 equals 0. Or I could also write x squared minus 2x minus 4 equals y. Now I can enter that into my calculator. Let's go to y equals. I'm going to clear that function and then enter the one I want, which is x squared minus 2x minus 4. Again, I need to graph this because I cannot factor this function, and also it's not set up for the correct method to use square roots. Let's graph the function. I can see the function pretty well, so I notice that I have two x-intercepts, and I can try to locate them by using my table. So second graph. Now I need to find out where my y values go from positive to negative or negative to positive. Here's my first one. Here's my positive 4 and negative 1, and therefore my first intercept has to be between, on the x-axis, between a negative 1 and a negative 2. So my first intercept, or first solution, has to be between these two values. But from the calculator, I knew I had other values, another x-intercept, so I have to find another sign change. And I keep scrolling, and I notice I have one here. My y values go from a negative 1 to a positive 4, and that's between my x values of 3 and 4. So my solutions are going to be between negative 1 and negative 2, and 3 and 4 for my x values. So let's calculate them. Second trace, which will calculate, number 2 for calculate, and I want to go to the left of my x-intercept, which is going to be above the x-axis. So I need a positive y value. Here I have a positive y value. I hit enter. Now I'm going to scroll to the right until I get a negative y value. I get that right there. Press enter. It asks to guess. I press enter again, and my solution, I get a y that's 0. That's what I want. And I have an x value that's a negative 1.23, so a negative 1.2. Or I could also say a negative 1.2 comma 0 for my x-intercept, but my solution is a negative 1.2. As you can see, it falls in between the range I found on my table. I need to find another one between 3 and 4. So I go back to my calculator, second trace, 2, And I want to scroll to the other x-intercept on my graph. To the left of my x-intercept is going to be below the x-axis, so my y value is going to be negative. I want to get as close as I possibly can. Here I have a y value that's negative. It's very close. I hit enter. I scroll to the right until I get a positive y value. I got that. I press enter again. It asks to calculate. It gives me a y value of 0, which I want, and my x is 3.2. Or my x-intercept is 3.2, 0. So you can see my solutions to this function are negative 1.2 and 3.2. And notice both of them fell between the range that I found on my tables.